Alright, so if we're looking to factor this, I'm going to use a method. I call it the magic method. I don't know of any particular name. But I'm going to put my parentheses up and do the 3x in front of both. I'm then going to look at the product of the a and the c term. So negative 24, and I'm going to find the factors of negative 24 that give me this positive 10. So I could list through them all. I got a 1 and a 24. I got a 2 and a 12. Oh, wait a second. That would probably be it. 3 and 8. 6 and 4. Oh, it could be the 6 and 4 too. Right, so which one is it? Well, I know that the signs have to be different because it's a negative 24. So this 6 and 4 down here is not going to be it because the signs would have to be different. If I want to get a positive 10, I need a negative 10 and a positive 12. So I'll just go back over here and put in that negative 2 and that positive 12. Again, this is not equivalent to the 3x squared plus 10x minus 8. But if I look at this term, it has something that I could factor out. 3x minus 2, I could factor out a 3. I'm left with x plus 4. So since I added an extra 3 in that very first step, I get rid of this 3. And so 3x minus 2, x plus 4, that is it factored, and to solve for x, set each piece equal to 0, and that's where we'll get our 2/3 and our negative 4, similar to what we just saw on Desmos. Looking at this one, so this one has 4 pieces. Usually when you have 4 pieces, you try to set it up by grouping. With this plus x, I'm going to call it plus negative x, and group it that way. So on this first piece, I could factor out a 4x squared, and I'm left with an, oh, very nicely, it looks like an x minus 8. Almost what I have up here. So why don't I just take out a negative 1 there, and now I'm left with x minus 8. So now I can do a factoring by grouping. These are the same piece, so it's just the coefficients of that common term, and then x minus 8, the common term. Now 4x squared minus 1, that is something, that's the difference of squares, so I could factor that. That would be a 2x plus 1, a 2x minus 1, and then an x minus 8. Again, if I'm solving for these, I am setting them equal to 0. So now I could just set each piece equal to 0. So 2x plus 1 equals 0, 2x minus 1 equals 0, and x minus 8 equals 0. And that'll give us the solutions that we saw on Desmos of negative 1/2, positive 1/2, and positive 8.